Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhiday Namdar, Senior College. Now, in groups and coding theory, we start with the last unit, that is coding theory. Now, see first introduction. Now, data transmission plays very important role in today's modern world. This transmission takes place in various ways. It can be a telephonic conversation or a computer terminal interaction through a satellite or any other way through electronic media. The basic problem in the transmission of data is that of receiving data as sent with least distortion. Distortion is caused by a number of factors. One factor is noisy channel of transmission. Coding theory is an important branch of mathematics that is developed to understand the transmission techniques. It uses the knowledge of group theory as a base. This theory helps in detecting and correcting errors of transmission. Security of data transmission is another important aspect that is used rigorously in data science. See, when one person sends message to another person, while sending that message, secrecy is very important because other than that, second person, third person should not know what is the message given by first person to second person. So secrecy is very important in data transmission. First point, coding of binary information and error detection. When we send message to our friends and family, normally we use the mother language or English language. For example, if some person is living in Maharashtra, he speaks Maratha, then he can use Marathi, which is mother language, for sending the messages. If some person is living in Karnataka, then he can use Kannada for sending the messages, like that. These languages consist of finite number of alphabets to construct meaningful words. Similarly, in binary messages, we use only two symbols, which are 0 and 1. So these are the set of alphabets and is denoted by b equal to 0, 1. The basic unit of information is called a message. Now, b equal to 0, 1 is a group with respect to addition modulo 2. So here the concept of group appears. Now already we have seen in the second and third unit about group that group G star is a non-empty set together with a binary operation star satisfying certain properties, namely associativity, then there exists identity element and inverse exists for every element. Now here b equal to 0, 1 is a group under the binary operation addition. Now the composition table is given below. As it is a finite set, here we have prepared the composition table. Now how the elements are added? So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 0. So B can be looked upon as Z2 with addition modulo 2. Now we have seen Zn with addition modulo n, in which we add a bar and b bar in such a way that it is the smallest negative integer obtained as remainder. Then a bar plus b bar means a plus b bar is divided by n. Similarly, here we are adding the two numbers and then we are dividing them by 2. So whatever is the remainder, we are writing it as addition. So here 1 plus 1 is 2, but 2 when divided by 2, we get 0 as the remainder. So this is the table. Now from table it is very clear that addition is a binary operation because we are getting the elements after addition as 0 and 1 only. Next, addition is associative clearly. Now the first row matches with this row, first column matches with this column. So the corresponding element is 0. So 0 is the identity element. Now inverse of 0 is 0 and inverse of 1 is 1. So all the properties are satisfied by b equal to 0, 1 under this addition. So it forms a group. Now product of groups. Let G1 star 1 and G2 star 2 be two groups. then G equal to G1 cross G2, the Cartesian product of G1 and G2 is a group with the binary operation star defined as follows. Now, as we are considering G1 cross G2, every member of G is in the form of ordered pair. So, we are taking two elements as A1, B1 and ordered pair A2, B2 from G. Now, how star is defined? A1, B1 star A2, B2 is equal to, now as A1, A2, the first elements are from set G1 and G1 is grouped with respect to star 1. For A1, A2, the operation will be A1 star 1, A2, comma. Similarly, what is the second element? Second element is for B1, B2 belonging to G2 as star 2 is a binary operation on G2. We apply it on B1 and B2. So it is B1 star 2, B2. So in this way, the first element is obviously unique element of G1 and this is a unique element of G2. So this is a element of G1 cross G2. So depending upon the binary operations on G1 and G2, we define the binary operation star on the Cartesian product set G1 cross G2. Now, under this operation, G1 cross G2 forms a group. Now, see, similar to product of two groups, if you consider another group, say G3 with star 3, then G1 cross G3, again a group. And elements in this group will be in the form of triplets like A1, B1, C1, A2, B2, C2, etc. Now, we generalize this concept of product of groups as follows. If G1, G2, Gn are groups, then the Cartesian product G1 cross G2 cross Gn is a group under the binary operation defined as follows. Now, as this is a product of n groups, every member of this group is in the form of n tuple. So, we consider A is equal to A1, A2, N and B equal to B1, B2, Bn as elements in G. Now, we define AB is A1, A2, N into B1, B2, Bn as a1, B1, comma, A2, B2, and so on, An, Bn. So the first element A1, B1 are from G1. So whatever is the operation on G1, that will be applied on A1 and B1. Same way, A2, B2, these are elements from G2. So the binary operation of G2 will be applied here. In this way, first element is in G1, this is in G2 and so on, this is in Gn. So definitely this n tuple will belong to G1 cross G2 cross Gn and under that operation it forms a group. Now some important notes. First, the set B equal to Z2 is equal to 0, 1 is a group under the binary operation addition or addition modulo 2. Second, as B is equal to Z2 is equal to 0, 1 is a group under binary operation addition or addition modulo 2. Bm, that is B cross B m times, which is Z2m, is a group under the operation ring sum defined by x1, x2, xm, ring sum y1, y2, ym is equal to, here first element is added in first, second in second, and so on. So x1 plus y1, x2 plus y2, and so on, xm plus ym. So here we have used the concept of Cartesian product G1, G2, G1 cross G2 cross Gn as a group. So as we know that BZ2 is a group, we have considered here B cross B m times, that is Z2m, which is a group under the ring sum operation where elements are added coordinate wise with respect to addition or addition modulo 2. Now order of the group Bm is equal to Z2m is 2 raised to m. Now what is the identity element? So 0 bar, that is 0 0 0 m times is the identity in Bm and every element is its own inverse. Now fifth one, an element of Bm is written as B1, B2, Bm or simply B1, B2, Bm without commas and without bracket. We call this sequence B1, B2, Bm a word. In communication, there are three essential parts, namely transmitter, channel, receiver. In daily practice, the communication channel is subject to variety of disturbances called noises. These disturbances occur due to lightning, sunspots, force in magnetic tape, etc. Coding theory deals with the transmission of a message where error may occur, could be detected, and if possible, corrected in an efficient manner at the receiver's end. So, coding theory studies transmission of messages, then detection and correction of errors. Now, see how the messages are transmitted. This is the message that some person wants to send. Now, by doing some coding on that message, we get the encoded message to maintain the secrecy of that message. Then it passes through transmission channel. Then the received message, which is in encoded form. So, after decoding, the person gets the decoded message. Now, some basic definitions. Message. A message is a finite sequence of characters from a finite alphabet. We shall choose our alphabet from the set B equal to Z2, which contains 0 and 1. So all the messages are in the form of 0 and 1. Word. A sequence of letters from an alphabet from the set B is referred as word. Code. A code is a collection of words that are to be used to represent distinct messages. Code word. A word in a code is called a code word. Block code. A code consisting of words that are of the same length is called a block code. Now, the basic process of sending a word from one point to another point over a transmission channel is shown in the following figure. See, an element X belonging to BM is sent through the transmission channel and is received as an element XT belonging to BM. So here this represents the word X in BM, which is transmitted. Through transmission channel, it is transmitted, and after that word X in BM is received. In practice, the transmission channel can have many disturbances due to weather interference, electric problem, and so on. And due to this, error may be 0 may be received as 1 or vice versa. If an error has occurred, then the word received is different from the word that was sent. That means if the actual word sent was X and the received word is XT, then we get difference in that. So X not equal to XT if they are differing in at least one position. In case there is no error, X equal to XT and both X and XT belong to BM. Now see encoding function. Let n and m be positive integers such that n greater than m. A 1-1 function e from bm to bn is called an mn encoding function which represents every word in bm as a word in bn. If b belongs to bm, then e of b is called as a code word. Now here n and m, these are positive integers, means natural number where n is greater than m. Now what is the meaning of 1-1 function? 1-1 function is same as injective function. That means if we are considering any two distinct elements from Bm, then under that mapping E, their images must be different. That means if B1, B2, these are different elements of Bm, then E of B1, E of B2 are different, because actually why we have taken here 1-1 function in the definition, because if the two words are different then their code words must be different. We cannot use same code word for two different words. So to avoid that part, here the function is taken as 1-1. Now any b belonging to bm is called as the word, and whatever is its e image, that is considered as code word. For example, suppose m is 2 and n is equal to 3. So here n is greater than m. Then the encoding function e from b2 to b3 is such that e of 00 is 001. E of 01 is 010. E of 10 is 100 and E of 11 is 111. So here as E is defined from B2 to B3, B2 is actually B cross B, which is 00, 01, 10 and 11. So the set containing 00, 01, 10, 11 is B2, which is domain of this function. Now as encoding function is 1, 1 for any two different elements of B2, their images must be different. So see here, all the four elements are different. It means when these two are different, we are getting their images are different, and same for all the pairs. So this function is 1, 1. So this is one encoding function, and their images are triplet containing 0 and 1. That means they are members of B3. The above process of using encoding function is shown in the following figure. The encoding function must be one function so that different words in BM will be assigned to different code words. See, word B in BM is to be send. Then using encoding function, we get encoded word x equal to E of B, which is present in the codomain BM. Then through transmission channel, word xt belonging to Bn is received. Now, if there is no disturbances, then xt, which is the word received, is equal to x for all x belonging to Bn. But in general, errors or disturbances occur in transmission, and in that case we say that the code words x equal to E of B has been transmitted with k or fewer errors if x and xt differ in at least one and at most k positions. See, the encoded word x and the received word xt. So if they are differing in k positions at most, then in that case we say that k or fewer errors are occurring in the transmission. Now let E from Bm to Bn be an Mn encoding function. We say that E detects k or fewer errors if whenever x equal to E of B is transmitted with k or fewer errors. Now see the definition of Hamming weight or weight of a code word. Let x belong to Bn. The number of ones in x is called the weight of x. It is denoted by this symbol or W in round bracket x. So x belonging to Bn means x is an n tuple like x1, x2, xn. But every element xi is either 1 or 0. So number of ones in x is nothing but weight of x or Hamming weight of x. Now, in this question, we have to find weight of each word in B6. So, B6 means it is a sextuple. Now, here observe this element of B6. There are 3 ones. So, weight of this element is 3. Now, in this case, again, there are 3 ones. So, its weight is also 3. Now, here all are 0. So, there is no 1. It means its weight is 0. Now, if you count here number of ones, there are 5 ones. So, weight of this element is 5. So, in this way, we can easily find weight of the given word. Now, this is a specific encoding function mm+1 parity check code. The encoding function E from Bm to Bm plus 1 is called the mm+1 parity check code, where for B1, B2, M belonging to Bm, E of B is equal to B1, B2, Bm, Bm plus 1, where Bm plus 1 is 0 if weight of B is even and is 1 if weight of B is odd. That is, Bm plus 1 is B1 plus B2 plus Bm modulo 2. Now see, here is defined from Bm to Bm plus 1. It means every element of Bm is an m tuple, and in codomain we are considering the elements which are in the form of m plus 1 tuple. Now for B equal to B1, B2, Bm in Bm, E of B is defined as B1, B2, Bm, which remains same. Means first m tuple remains same, and we are adding one more element, that is Bm plus 1, where Bm plus 1 is 0 if weight of B is even. Means in that m tuple B1, B2, Bm, if number of ones are even, then we are writing that last element as 0. And if weight of B is odd, then we write element as 1. It means weight is odd means number of ones in B1, B2, Bm are odd in number. Then we are taking here 1. It means total number of ones become even in any case. Now, similar to this, actually, you can define Bm plus 1 as B1 plus B2 plus Bm mod 2. Because if weight is 0, then Because if mod of b is even, then b1 plus b2 plus bm is an even number. So even if we divide it by 2, then we get the remainder as 0. So we write bm plus 1 as 0. And if weight of b is odd, then we get b1 plus b2 plus bm an odd number. And in that case, odd number, if we divide it by 2, we get 1 as the remainder. So you can define encoding function e, which is plus 1 parity check code, either in this way or in this way. Both are same. Now find 3-4 parity check code. Now 3-4 parity check code is nothing but the encoding function E defined from B3 to B4. Now B3 means it contains 2 raised to 3, that is 8 elements. So every element of B3 is in the form of triplet using 0 and 1. So for every such element we find all the code words. That is nothing but finding the 3-4 parity check code. Now by definition of parity check code function, for every element B1, B2, B3 in B3 we write E of B1, B2, B3 is equal to B1, B2, B3, B4, where B4 is equal to B1 plus B2 plus B3 modulo 2. It means if weight of this element is even, then we write directly B4 as 0. And if weight is odd, then we write that last element B4 as 1. Now what is B3? 0 0 0 0 0 1 0 1 0 1 double 0 0 double 1 1 0 1 double 1 0 and all 1. Now how to write all the code words? See, E of 0 0 0. Now first three elements will remain as it is, that is 0 0 0. Now here the weight is even, which is 0. So last element is 0. Now E of 0 0 1. So it is 0 0 1 and its weight is 1 because there is only 1. So as it is odd, we write here last element as 1. Same way for 0 1 0 and 1 double 0. Now observe E of 0 double 1. Now here two ones are there, so its weight is 2, which is an even number. So we write last element as 0. Same way for these two, their weights are even, so we write last element as 0. And for triple one, weight is 3, which is an odd number. So we write last element as 1. Now see the remark. The bit B4 of E of B is 0 if weight of B is even. Else B4 is 1. That is, if B contains even number of ones, then B4 is 0. All else B4 is 1. This implies that every code word E of B has even weight, because if already the weight is even, we are writing at the end 0. So weight remains same. And if the weight is an odd number, then we are taking last element as 1. It means that weight becomes even. So in any way, every code word E of B has even weight. A single error in transmission of code word will result in a received word with odd weight. Hence, error can be detected. Similarly, any odd number of errors in transmission can be detected. Now see second example. Consider the following M3M encoding function E from BM to B3M, defined as for B equal to B1 B2 BM in BM, E of B equal to B1 B2 BM, B1 B2 BM, B1 B2 BM, that is 3 times. For M equal to 3, write the code words. Now as M is equal to 3, the encoding function becomes E from B3 to B9. So here the domain is B3 again, which contains 8 elements, and B9, it contains the code words which are of length 9. Now E is a map that repeats the word 3 times. So that is the definition of this encoding function. So we use that definition, which is very simple. Now apply E on every element of B3. So E of 0 0 0. So this is a triplet. So we have to write it 3 times. So total 9 zeros will be there. Now second is E of 0 0 1. So again write 0 0 1 3 times. That is the code word. So in this way last is E of triple 1, which is 1 1 1 3 times. So total 9 ones will be there.